Today, as was announced, I'm going to talk to you about how to use Go to do real-time video capture. And like I said, my name is Vladimir. I'm a software engineer. I've been known to write a couple books, so that's something I do when I'm not writing code. But today, the agenda for today is I want to show you and convince you that you can use Go to stream live video data directly from a video attached to a video capture device attached to your Linux machine. And why would you want to do that? Because you can do something like this, live videos. Is it live? Yes. So let me see. Yeah, there you go. There you go. So anyway, and we'll talk about how to do this throughout the talk, so don't worry. It's kind of dark, that's why it's like that. As with any good story, the origin of my story with this is COVID. I don't know if you remember a couple years ago when we were all forced to stay home and turn into Zoom zombies, and we all were looking for cameras, and I was doing the same, and I couldn't find any. And of course, as any bored engineer would do who's going through a world pandemic, what do? You convince yourself that you can build a USB webcam gadget using the Raspberry Pi and the HQ Cam, which is basically this thing right here. And I want to do it in Go, why not? And how hard can it be? You know, naively, that's what I asked myself. Well, that was the next reaction. First of all, it's a lot of C code, sorry. You have to learn about Linux drivers, USB video class drivers, building UVC gadget. If you don't know what any of this, what they are, that's okay. Video for Linux API. So all this stuff I had to learn about. So I kind of regroup. I'm like, okay, wait a minute. There's a pandemic outside. Let's just figure out how to use Go to capture video using the video for Linux. So that's what I did. So let's talk about the video for Linux API. It's part of the Linux specs for media infrastructure. It's a large spec. It's all C, and you have specs for device driver writers and user space application developers. For user space application developers, there's tons of system call define so that you can interact with the device. Well, how do you go from Go to video for Linux 2? Well, since I mentioned system calls, well, the first place we're going to start is the Unix package so we can make our system calls. And we're going to pepper a little bit of cgo. Now, you may say, well, I thought we were talking about, pure Go. Yes, the way I'm using cgo here is just to pull in header values and types from the video for Linux API, and that's it. And then a lot of unsafe calls to make the magic happen, and we'll see some of that. So what system calls do we use? Well, we're going to do open, close, so we can get a file descriptor for the device. We're going to use IO control. This is the way we're going to talk to the device and ask the device to do things for us, such as start capturing. And we're also going to, at least for this use, we're going to use memory map and memory unmap so we can map the device buffer onto our local memory address space. So we can do zero copy IO. Now, having said all that, let's see how to capture one single video frame using Go and everything we just described. Okay, first, we're going to use the synthetic C package to pull in our values, as we said, and I have also defined a PIX format type that I'm going to use to send data to the driver. Next, since we're going to make a lot of IO control call, I'm going to wrap that in a nice function called IO control so I can reuse it all over the place. Next, we're going to open the device so we can get the file descriptor, because all the subsequent calls will require the file descriptor. The first thing we do is set the video format. Well, how do you do that? So here we get to see what really goes on to make the call work. So we declare a type generated by syscall for us. We fill that type with the parameters that we want to send to the driver. And once we do that, we call the IOCTL function we saw defined earlier. And we specify a request, which in this case, we want to do video ICS FMT. This is a V4L2 request. And then we passed it a pointer to this value that we declared earlier. If everything goes well, you won't get an error. If something happened, you'll get an error and you have to figure out what happened. Next, you have to request the buffer. You have to ask your device to set up the buffer for you. So that's another IO control call. Same thing here. We use a type that was generated by syscall for us. We fill that in, and here what we're saying is we want one buffer. You can have however many buffers that your device support. But in this case, we're just capturing one frame. We just want to do one, and we tell it that we want that buffer to support a video capture, which is what we're doing. And we also set the IO type to be memory map. Same thing, we call IO control, and we request the buffer. Yes, Jean-Luc is, oh, come on. Please tell me you're done. Sorry, Jean, we're not done. More. Next, you have to map the buffer. Since we only have one, we're going to map the buffer at index 0. And the way we do that is pretty much the same way. We use a syscall generated type, fill in the values that we need, and then we call the query buffer so we can get information about that buffer. Next, we use the system mmap to actually create that mapping that I had mentioned earlier. And at the end of that call, you should get a slice of bytes that you can use to get values from the device. Then you can set up the buffer to query. There's a reason why I'm going through all these steps, and you'll see why later. You have to queue the buffer, so you can tell the driver that you actually want to capture data. Once you queue the buffer, once you queue your buffer, you have to request for the video to start. So you send a video stream on, basically signaling to the device that you're ready to start streaming. After you do that, then you dequeue. You have to ask the buffer or the device to dequeue the buffer for you, which indicates that you are ready to consume the data from the device. And finally, at that point, you can get access to the frame, and then you can process it. In this example, I'm simply grabbing the data and write it to a file. Okay? So, more crying. This is not what I want to do. There's a pandemic out there. I don't want to do, I didn't want to do that just to get one image from the device. There are no less than 10 steps, and I've omitted some, by the way. I didn't go over all the steps that you need to get this to work. And it requires you to have an intimate understanding of the Video for Linux control commands. And if you don't, you probably will make those call out of order, which will make you cry, because those errors are usually cryptic, and you will have to go back and read the documentation for like a couple of days. Again, there's a pandemic outside, or use strace trying to figure out what's going on with your device. Can we do better? Yes, we can. So I spent about a year and a half learning about video for Linux, and I captured everything that I've learned in a packet or in a project called GopherVL. So everything you just saw is in there. What I wanted is to expose an idiomatic Go API with primitive that hides all that stuff we just went over. So here's the same capture one frame using the GopherVL package. So it's done in a few lines. That's it. That is it. That's all that you have to do. But the first thing that you do is you open your device. Once you open your device, you can configure it right there. You can ask for a pixel format, set the size of the image that you want. In this use, I'm setting the buffer size to be 1, but you can set it to be whatever. Or if you don't set it, a default will be selected for you. Then we start the device, and we pass it a context, because in some instances you might want to use the context to cancel once you've started the device. And then we call device get output, which returns a channel. We use that channel to get 1 frame, and that's it. And once we have that frame, we can process it. So before I go on, let me show you what I have up here. And this is, from this point on, we're going to talk about demos. So this is what I have spread around me. I have a Raspberry Pi 3 with an external USB attached camera. And you may be wondering, why the 3 and not the 4? Again, pandemic, you can't find Raspberry Pi 4. And if you do, they're like crazy expensive. But this one works fine. It's a 32-bit and it works just fine. And down here is the original Raspberry Pi 0 with the HQ camera attached to it. Now, GopherVL or Video for Linux works for any Linux, really. I wanted to bring something I can carry around so I can demo this, but it will work on any Linux. So I wanted to point that out. All right. Actually, before I move to the, let's take a shot. Let's do some demo here. All right, we're gonna go to snapshot, which is the first one. All right, so I've already compiled, yes, it's already compiled. But I am gonna take, just to show you that this is for real, I'm gonna go and snapshot this. And I'm gonna ask you audience for, I don't know if I can see you, but we'll try. You should, all right, no sound, it's just Video for Linux, I'm sorry. Sorry, next talk. But let's see what we got. So we're gonna go, oh, I didn't want you guys to see this one, but anyway, not yet. All right, snapshot, let's see what we got. Pick that JPEG, there you go. Pretty cool, right? Yes, thank you. All right, what else can we demo? Okay, taking multiple shots. Now that we have a Go API, we can do some interesting stuff. We start with the same thing we did earlier. We open the device, set parameters for the device. We start the device. And now, instead of grabbing 1 frame, I can grab a multiple frames, because get output returns a channel of slice bytes. So I can just sit there and iterate through data from the channel and do as and process it. So what we're doing is grab the frame and basically doing the same thing we were doing before, but we're generating a unique name for each image. And as we're going through and capturing image, we create a file, we write the frame, and we close it. And if we reach a total of frames, then we stop, and that's it. So let's see how this guy works. Yes, I think. Oh, wait. Capture, there you go. Okay, so we're gonna, yes, it's already generated. All right, let's see. Okay, I think it's set to run for 10 frames, so let's do another demo. Okay, so there you go. There you go. And you can see that we have frames capturing, and when we get to 10, it should stop. There you go. All right, now let's see what we got. This one was capture. There you go. You should see. Oh, wait. There you go. We got 10 frames. Let's see what we got. See people waving, people falling out of chairs. Let's see what we got. Yes, people just moving around. Again, all live. Yeah, so as you can see, this is all live, and it's happening in real time. All right, let's go to the next one. Now that we can take multiple shots, what else can we do? Well, naturally, we want to create a streaming image server. What do you mean, Vladimir? Well, we're going to take our device and continuously grab a video frame from the device and push that to the browser. So let's see how we did it. So same thing, we open the device here, defer, close the device. We start the device. Now, we grab the output and assign it to a package level variable here so that we can get to it in the next function. We mount our path for the handler func for this path, and this is hit down here. So this function is basically a regular HTTP handler func function. But what we're doing is we start a multi-part MIME header, and we're going to push down image JPEG format to the browser. And then in the loop, just like we saw earlier, instead of saving it to a file, we're going to use a MIME writer, a part writer, to send or write that each frame to the browser. So how does that work? We already saw how it works, but I'll rerun it again. So, by the way, this is it right here. This is that's the actual code that's running on this guy, but I'll rerun it on the other camera that I have. Yes, I see. So, all right, let's rerun it on this camera that's up here, or this Raspberry Pi, I should say. All right. What was it? Simple cam. There you go. All right, simple cam is already. All right. Okay, so now I'm basically running the same code on this device. Let me switch to here so you can see it. Stream. There you go. There you go. So what you're looking at is this camera capturing me, or I do see the, so maybe I should do it like this because I have the infinity mirror in the back. We don't want that. Okay, so basically that code is running on my Raspberry Pi that's down here, and it's capturing all the frames from this camera and pushing it to the browser as JPEG. So pretty dope, pretty cool. I thought so. Thank you. All right. Wrong button. All right, so what else can we do? Well, we can build a webcam application. What do I mean by a webcam application? Well, what we just saw is basically something that pushes raw image to the browser. What if we take that same application and we wrap it in an HTML and we send some pretty GUI to the browser? So this is exactly what we're going to do. So let's look at that example. I'm going to stop this guy. Webcam. So these are the files, and you could see I have the Go binary here, but I also have an HTML file that draws the GUI on the browser, which we'll see in a second. And actually, let's go ahead and run it. All right, that's me looking down. Webcam. There you go. Again, infinity mirror. I don't know, maybe I'll point it this way. Okay, so as I'm filming, I'll talk about what's going on here. So this application shows other capabilities of Video for Linux. If you look on the left side of the screen, what you'll see are controls that Video for Linux give you to basically change the image as you capture it. So I can actually come here and hit on bright. You could see the image, the brightness changing, or I can change the contrast. There you go. Let's go some, yeah, or the saturation, make it black and white. And all of that is nothing that I'm really coding for. They're still the same thing, the same approach. I'm sending command to the device, and the device is applying my command, and I'm getting the feedback real time because the image is changing. All right. So I thought that was cool. And I wanted to point out, as I was playing with the sliders, I'm outputting the values that are changing. And the thing about Video for Linux is that it allows you to apply a lot of controls, or not a lot, but controls that the actual device advertises that it supports. In this example, I didn't do it dynamically. I just put some controls there, but I could have done it dynamically where I query the device for its capability, and it would have returned a list of supported controls. Matter of fact, let's look at some examples of what else you can do with Go4VL. All right, I'm going to stop this example. And we're going to look at device info. Oops. All right, device info basically shows you other capabilities of Video for Linux. I'm going to ask, device info is a simple program. Actually, let's see if I have that up. Oops, sorry. There you go. Do I have device info? No, let's open it up. We'll look at it real quick. Okay, time is good. These are all the examples here. There we go, device info. All right, so I just wanted to show you, this is actual code instead of being in the presentation. So device info allows you to query the device itself and discover its capabilities. I'm not going to go through all the iteration of what it does, but you can see it's the same approach. We open it, and for instance, we want to print device driver information. We pass the device that we just opened. If we go to device driver information, let's see what it does. There you go. You see that it does, yeah, it call capability on the device, and that returns a list of capabilities, and now we can print that information. And there are other things you can query the device for. For instance, here we're asking for input info. Same thing. You ask for get input info or get input index. Here we're actually asking for input info, which is a little bit more, and then we print that info. Print format info, that's another one. Format, when you do get pixel format, you get a chunk of information that you can use to make a decision on, because that call returns pixel information that the device supports. So you may want to do something, or you may want to check that call to make sure that the device supports something that you want to do. So again, I wanted to show you that you can make that call with Go4VL, and it will return the information, and we are printing the information. So let's run this real quick. So this will give me information on this guy. And we see that, and this is the the attached camera, sorry. It gives you the driver name, the card name. That was the first call, print driver information. You can get the bus info. And all of that information is nothing I'm generated. It's being returned by the driver. Yeah, you can get pretty much anything from the device. And here we see what video format that the driver support: MPEG, MJPEG, and YUIV. So I'm using MJPEG because the browser can freely decode that for me. I don't have to do anything extra, and it'll show up in the driver in the browser. If you use anything other than that, then you would have to provide your own decoder and pop that image somewhere where you can show it. And we could see other information, like, for instance, we see the frame per second, or FPS, which is, you can change, you can lower it, and we'll see that soon. Or you can put it at a ridiculous value, but the driver will ignore you and set it at whatever value is supported. Okay. And let's look at one more. User control, that's the one. All right, it's kind of hard to see that one, but I'll do this. And these are all the control I was mentioning earlier that my device support. We see brightness, we see contrast, we see saturation, hue, white balance, and so forth and so on. So for the little demo we did earlier, I just hard-coded the control and ask the device to ask the driver to adjust those values for me from the browser. But you can imagine creating an application where you dynamically query those capabilities and build a UI accordingly. So I just wanted to show that. Okay, what else can we demo? Is there anything else? Anything cool? One more example, a webcam with face detection. So before I show that, I want to shout out Pion, and which I stole the idea from because they pointed me to PyGo, which is a pure Go face detection package. So let's see if it works. All right. We'll go back to our webcam, and then we'll do webcam. Let's see. Webcam face. All right, now it's starting to run. Let's see. Let me reload my webcam, and let's wait. There's a lot of light behind me. Okay, let's see. Oh, wait. I need to turn it on. That would help. So, okay, let's turn it on. Okay, now let's wait. There you go. My face is being detected. Now you may notice that the image is a little jerky because what I've done is when I turn on face detection, I drop I don't know, you probably can't see it there. I dropped the frame per second to just 5, so that's why it's jerky. So if I turn it off, it gets a little better. So anyway, yes, face detection, and again, that's face detection with Go all the way. There's no external calls to anything else. PyGo does everything in Go, and once I figured out how to do it, I'm like, yes, this is going in that demo. All right, what are the possibilities? Well, there's a lot of work to be done to support the majority of video for Linux too. It's a lot of work, and what I just showed you is a very tiny slice of what the API can do. And I've only done what I needed to do to capture video and to build these little applications that you saw. But there's a lot more to be done. We can imagine, I still want to do a true USB webcam gadget. I want to turn this thing into a webcam gadget where I have a single binary loaded on there and plug my USB, and it shows up in my camera list. I want to do that. It's possible. I just haven't had time, but I know it's possible. This is something I'd like to get to. You can imagine edge computing applications, right? You have little devices and you put them somewhere and they're capturing images for a number of purposes, including security, motion detection, lighting, or ambient, or whatever's happening in a remote location. Definitely more possibilities. And we've reached the end of the presentation, but what I wanted to make sure that I have convinced you that Go is the right language where you can do cool things like direct video capture from your device. Did I do that? Awesome, thank you. And I also challenge you, when you approach Go, yes, Go is not meant to be a system language. I understand, but Go can do a lot of things that you don't think of when you think of, when you think of Go. So I had to convince myself that this can be done in Go, and after a couple years of research, really, and the answer is yes. So thank you for coming. I appreciate your attendance, and that's it.